You know, you're probably manually checking every single API response during incidents, but let me tell you, there's a way faster method. Welcome to this explainer. Today, we're taking a look at how to transition from the tedious grind of manual API testing to a highly automated, senior engineer level workflow. If you build or troubleshoot APIs, you already know Postman, but we're going way beyond just hitting send. We're talking about writing dynamic scripts that actually do the testing for us. Look, we've all been there. Actually, scratch that. If you've ever dealt with an active outage, you know the exact pain I'm talking about. You're hunting through massive JSON payloads with tired eyes, desperately trying to spot a missing parameter while the clock is ticking. It's incredibly stressful and, let's be honest, completely prone to human error. But our source material maps out a much calmer, methodical way to isolate and validate these exact issues. It's honestly like night and day. On one side, you have the manual trap, visually scanning line after line of JSON just hoping you spot the missing field. On the other, a clean, automated solution. Tests running right inside Postman's native environment that catch errors instantly. You fire off the request and the script immediately tells you if the data meets your exact contract requirements. All right, part one. What are prerequisite scripts and how do we set the stage? So what actually is a pre-request script? Basically, it's Node.js-based JavaScript running right inside the Postman sandbox. And the real magic here is that it executes before your API request even fires. It lets you intercept the workflow and dynamically alter the state of your request before it ever leaves your machine. This is where it gets incredibly powerful for modern security environments. Sure, you can use these scripts to clear variables or set simple dynamic timestamps with the built-in Faker library, but you can go so much deeper. You can leverage the built-in Crypto.js library to calculate secure, dynamic HMAX signatures, or even handle wild, complex workflows like AWS Signature version 4 on the fly. No more calculating that stuff manually for every single call. And you know what? The syntax is literally a one-liner. With a simple pm.environment.set command, you've programmatically defined an environment variable. You're dynamically setting up the exact headers, parameters, or body payloads you need, just milliseconds before the API request actually fires. Moving into section 2, writing your first PM test.assertion and automating the validation. Building these tests always comes down to a super simple 3-step rhythm. 1, you fire the request. 2, you parse the response data, usually just grabbing it with pm.response.json. And 3, you assert your expectation. Postman has the chai assertion library built right in, so you can use this highly readable behavior-driven development or BDD syntax to state exactly what you expect the API to spit back. You absolutely have to start with a baseline, right? So here is a basic assertion written in the post response tab. It uses PM test to instantly validate that the server actually returned a 200 OK status code. If it returns a 500 or a 404, boom, the test fails, and Postman flags it right away. But hey, a 200 OK doesn't mean much if the API is dragging. You can easily assert that the API is performing well under load by checking the response latency. Just use pm.expect to demand that the response time stays strictly below an acceptable threshold, like 200 milliseconds. And to guarantee the actual payload isn't garbage, we parse the response into a JavaScript object. From there, you can drill right down into the JSON and assert that specific body fields match your exact expectations. In this case, we're strictly verifying that the name field equals Jane. Okay, section 3, chaining API requests to pass data dynamically. This right here is where you truly level up your API observability. The whole strategy is grabbing a crucial piece of data from your first response, saving it as a variable, and then seamlessly injecting it into your next request. For example, imagine request A creates a new user. In the post-response script for that specific call, we parse the JSON, grab that shiny new ID, and save it straight into a local environment variable. Let's call it cust_id. Next, we hit a completely different endpoint, like the public Postman Echo API. By using double curly braces in the URL, we pull in that exact dynamic cust_id value. We've completely eliminated manual data entry. It creates a flawless, end-to-end data flow that simulates actual application behavior. Section 4, catching silent API failures. This is the real-world support scenario. Okay, picture this. You've utilized Postman's mock server feature to simulate a payment API for your front-end team. The mock server returns a nice, comforting 200 OK status. The payload even says success. But if you look closely at the critical transaction ID field, it's returning a null value. If this slips into production, it's a silent bug that's going to cause massive downstream failures purely because the database won't have a record of the transaction. And this is exactly how the human eye gets tricked. During a chaotic incident, you see that big green 200 status, and you just move on, assuming the endpoint is healthy. But our robust automated test script, it couldn't care less about the green 200. It instantly flags the red failure, catching that null value before it impacts a single customer. To catch a silent killer like that, we write a test using Chai's chainable methods. We don't just stop at the HTTP status. We parse the JSON and explicitly demand that the transaction ID is not null. We can even take it a step further and enforce the data type, making absolutely sure it's a string. And honestly, that hits the nail on the head for the core philosophy here. Automate the validation so you can focus on the engineering. When you let pre-request scripts handle your complex auth and post-response tests enforce the strict contracts, the tedious validation is totally handled for you. It frees up so much of your mental bandwidth. So I'm going to leave you with a question to think about. How many silent API failures are slipping past your manual checks right now? Seriously, think about your current development workflows. Boot up your Postman instance today, pull up a critical API you manage, and ask yourself, what can I start automating right now to make sure I never miss a silent failure again? Thanks for hanging out with me for this explainer, and happy testing.